Uh, Welcome again. Welcome to episode 17 of Redesigning Cities, the Speedwell Foundation Talks at Georgia Tech. If this is your first Redesigning Cities event, I invite you to visit YouTube, your favorite podcast platform, or our website to check out the videos and podcasts from previous episodes. Before I talk about today, you can see here all the really great episodes we've had. Let's see, it's not going forward. There we go. So before I talk about today, I really want to encourage you to mark your calendar for April 14th, when we'll be having very special guests, Raphael Bostic, President and CEO of the Federal Reserve Bank of Atlanta, and Catherine Ross, Regents Professor of City and Regional Planning at Georgia Tech, on the subject of redesigning cities to end racism. Today, our topic is redesigning cities with green infrastructure, with a particular focus on water in its various forms: natural hydrology, water supply, and wastewater. How do we use green infrastructure to help cities address both sea level rise and drought, as well as urban rivers that are moving? How do we rehydrate cities to cool them down? And how do we convince the drafters of the next federal infrastructure bill to finance these systems as both social and green infrastructure? Our speakers who will explore these and other questions. But before I introduce them, I want to go through just a few logistics. So we really welcome you to post questions in the Q&A and to like each other's questions. You're also welcome to use event chat for comments, but we will not be monitoring that for questions. We'd also love for you to tweet both about redesigning cities and about Sherwood Engineering and Josiah. So you can follow all of us again on Instagram or on LinkedIn. Here are quite a number. Please take a screen capture if you'd like to capture any of these and tweet along with the presentations, or just follow us for later events. First, I want to introduce Mike Messner. So Mike was trained as a civil engineer at Georgia Tech and MIT, but made his career in finance. He founded both a very successful hedge fund, Seminole Management, and the Speedwell Foundation, which has supported numerous efforts to advance and advocate for urban parks and greenways, including this series, Redesigning Cities. He's also, the things that the foundation has supported range from a PBS documentary on Frederick Law Olmsted to pioneering research on retrofitting defunct commercial property into green space. He is currently a professor of practice in the Georgia Tech College of Business, where he teaches financing of green infrastructure. Mike is going to be joined by Josiah Cain. Josiah is co-founded Sherwood Design Engineers Innovation Lab in 2012, where he is the Director of Innovation as well as a principal and owner. His passion for enhanced site performance and multidisciplinary integration has led to first-of-a-kind permits implementing a wide range of resilient and regenerative policies and systems, several of which he'll share with us today. Trained as a landscape architect at UC Davis and Harvard, his previous firm was Design Ecology. Mike will introduce the topic today before Josiah presents some of Sherwood Design Engineers' innovative work. Then Mike will lead their discussion before I moderate Q&A. Take it away, Mike. I will stop sharing now. So Mike, if you can share your screen.
Okay, I will share my screen, and Is that working?
Not yet.
Okay.
There, I think it's coming.
All right. Is this good for everyone?
Yes. It's still not at full screen.
But I will put there. And is that good for everybody?
Perfect.
Okay, great. Thank you. Thank you, Ellen. You know, you go through this and you're spending 6 months on virtual meetings and you still don't get it right. So please be patient as I work through this. But anyway, I appreciate Ellen's kind words. As she mentioned, I went from civil engineering and very much interested in city planning, but ended up in the railroad business and then migrated when I lost my job in that field to finance, and then ended up running a investment hedge fund in New York City for 25 years or so. During that period of time in New York, went through the financial crisis in 2008 and 2009. And if people remember, the financial crisis had a big big issue associated with underutilized real estate and the effect it was having on the banking industry. The Federal Reserve went beyond its historical patterns and really backstopped a tremendous amount of real estate debt in the financial system. Then the federal government also provided some stimulus. One thing that I thought during that period of time that the Federal Reserve should be a little bit more creative. Instead of just backstopping bank real estate and let it sit there, why not do something about this more directly with the possible idea of buying potential underutilized real estate and taking it off the market? And we thought about how it could work, and we talked about land-backed securities as opposed to mortgage-backed securities. But anyway, the research was done at Georgia Tech, where we studied a dozen cities and looked at what would happen to these cities if we took a substantial amount of underperforming real estate off the market and turned them into green space. I think every city embraced it. Most of those same cities are using some of the work with their own urban plans. Houston is doing stuff with their bayous. Miami is working on its park system. LA is pushing pocket parks. So there's a number of initiatives that have sort of was helped with the research, even though we didn't get very far at the federal level. But I do think it galvanized the whole issue of urban parks as part of a real estate portfolio. As I said, we studied the different cities, including Cleveland. Cleveland especially has taken some of the work and looking at how they can make their rivers more livable and manage their water systems with a green infrastructure in mind. At the same time, in order to encourage the country to think about urban parks as part of the portfolio of urban real estate, my family foundation funded a documentary on Olmsted and America's Urban Parks. We were able to show it on public television. My daughter wrote the script and basically produced it, and very proud of this documentary. And what was very revealing was how foresightful Olmsted was back in the 19th century about how you could use green infrastructure to help cities' water problems especially. Recently, in conjunction with the City Parks Alliance, our family foundation funded a series of short videos on city parks, America's new infrastructure, on how parks and urban green space should be considered part of any type of infrastructure effort funded by the national federal government. If you want to see that, you could just Google city parks and infrastructure, and you'll be able to see these videos. I thought they were very well done, and it sort of encouraged, interviewed a lot of different people from around the country on that effort. And then finally, as I said, I'm teaching a course at Georgia Tech infrastructure finance. We're working on a number of green space related projects this semester, one of which is the Fourth Ward Park in Atlanta. And this is a unique piece of property where it's going to be an underground water tank to control flooding. And instead, they ended up redesigning the area for a park, and they ended up actually saving money and solving the flood control issue at the same time. So anyway, I've become a big believer in urban parks, the power of them. I think Atlanta is proving to be seeing the potential return on investment from green infrastructure. They've got the massive Beltline project going, but they also have a number of different parks they're also working on. And I'm seeing this throughout the country. And so it's been great to be involved in this area, and I've appreciated everybody I've met who are all very much keen on what the work they're doing in the urban space. One of whom is Josiah Cain, and we have never met in person, but Josiah clearly has a tremendous background who will be able to talk a lot about this area. So I'm going to turn it over to Josiah to let him talk about some of his major projects, especially around water and the management of water in urban spaces and how it can be done effectively and also with the benefit to the social environment. So Josiah, would you like to start and talk about a little bit some of your projects?
That sounds good. Hopefully everyone can see me all right. And I'll try to get my screen up. Assuming everyone can see that.
Yes.
So thanks for having me. Great. Awesome. Thanks for having me here today. It's an honor to be, and excited to talk about this material with all of you. I guess moving right into some of what we're looking at with cities. We have a lot of new problems, and we have some old ones, and in some cases some old problems that are coming to haunt us. Certainly sea level rise, we've all heard plenty about in our coastal cities where most of us live in the world. Drought is a big issue with water, and water supply issues are prevalent. We're also dealing with urban heat island, and I think this is going to be a very interesting area to get into in the relationship between overheating cities and water management. And flooding. We're seeing unpredictable precipitation rates and associated flows with stormwater, rivers, urban rivers in particular. So I'm going to talk about some of that as well. And, you know, it's a funny thing. Sea level rise is coming at us, and sometimes we forget that we had a lot of problems before sea level came around. But starting with sea level rise, because it's fairly understandable in an intuitive way. The ocean's getting higher. We need to either attack that with some kind of an edge, or retreat away, or learn how to adapt. We don't know, could be a little bit, could be 5 or 6 feet by 2100. There's a lot of different predictors out there, and it depends a little bit on how well we do. But what we do know is right now, today, in places like San Francisco and Miami, existing infrastructure is no longer functioning properly because sea level rise is already occurring. So it's already compromising infrastructure and causing a lot of money. For us, a really salient example of this was Brooklyn Bridge Park. We happened to be doing the civil engineering and controlling a lot of the grading and elevations and stormwater runoff when Sandy hit. And that was a learning experience for us, to be sure. We had been applying green infrastructure approaches for stormwater management, edging, some restoration work happening there, pervious paving, things like this. Looking at really a whole coastal resilience effort. When Sandy hit during construction, we had to actually go back and reevaluate many of these elevations, and sort of honestly couldn't be a better design tool from a certain point of view. But once again, looking at these sort of vertical edges, retreat strategies, changing the geometry, topography, all of these things, very important for protecting our coastal cities. Moving on to kind of like an extreme version of water supply issues, working on Sustainability Pavilion in Dubai with Grimshaw Architects. Massive project that went for, it's built at this point, so this is built photo, and this was supposed to open in 2020 for the World's Fair, but we do have a net zero water pavilion. The idea is energy, but all in the solar panels, but also a giant funnel for rainwater collection, working that into the landscape, a large green roof on podium. What that allows is for the little water that does come out of the sky is largely caught, and then every kind of water recycling you can imagine, and really highlighting those and making those part of the exhibit. It will live on beyond that as well. But the key here is that there actually is a shallow aquifer, and we're able to recharge more water into the aquifer than we take out. So essentially having built-in storage that's almost infinite, and the idea of kind of almost the equivalent of a battery for water. So you can put a bunch of water there and then take it when you need it. So between recycling and that groundwater interaction, able to get to net zero even in a place like Dubai as an extreme. Some of what it looks like right now. And then moving on to the urban heat island, beyond water supply in cities, cities are overheating. And we've known that for a long time. It's actually a very serious human health problem, which I'll get to. But generally speaking, what we're seeing is there used to be a living system on the surface of the planet that evaporates water from the ground and modulates temperature. So simply by removing that vegetation and replacing it with an urban geometry, that functionality has gone away. And before you even move into a city, it essentially starts to overheat and off gas. And so you already have this mass that's heating up, and to some extent can have some air quality issues. And then to make matters worse, much of that material is a heavy thermal mass. This is resulting in what has killed more Americans than any other natural disaster over the last 30 years. And there's a book been written about it. We've had major heat waves that exceed mortality rates from hurricanes, earthquakes, flooding, etc. Europe also recently had, or not recently, but several years ago, had a very extreme case that killed thousands of people. So it's not just a resource issue. I talked about the city just overheating on its own. Literally, to cool the city, we cut down mountains in the form of coal and burn them, and then we literally pipe in entire rivers, and we use the coal to evaporate the water to cool the city back down, which is the exact same process and function of vegetation in soil, drawing water out of the soil, solar radiation, evaporating water to cool the city down. So you start to see naturally, almost intuitively, can we get into trying to understand climate change, how cities might continue to overheat, what these hazards are, whether they be flooding, fires, urban heat islands, find some engineering approach to evaluating these different strategies to give us design solutions. And so we're bringing that into a CFD modeling environment. Can we understand where the trees are, where there's going to be shade, where there's going to be reflective materials versus absorptive materials that heat up, and strategically orient that. And this is where urban design and civil engineering, I think, have a bright future, because it's almost as if for the last 20 years or so, architects and urban designers have been working very hard to make cities better, and they have, and it's mostly around making buildings better. Buildings are far more efficient, both passively and actively, than they were 20 years ago. But we're noticing the cities are still not performing well on a whole, and I think that's where really trying to understand these urban design moves, outside the buildings, and not just from a pedestrian and mobility standpoint or from a placemaking standpoint, but really from a technical standpoint. How are the materials that we're applying affecting the overall performance, passive performance of the city as an object? We can do that by understanding inputs, weather data, building geometry. Different plant species behave differently, whether they have wide canopies for shade, whether they use a lot of water and evaporate that water, whether they're drought tolerant or not. Drought tolerance not always better if you actually want trees to be evaporating water to cool the place down. You just need a supply for that. And that may offset air conditioning water demands, which are, in my experience, about a third of commercial water use. So we're looking at energy and water, maybe applying that water to plants can be more efficient if it's done at city scale than applying that water to mechanical equipment. So that's a question that we can input. Material properties, what's happening with soil? Does it infiltrate? Is it exposed or covered? Mulch on top, things like that. And then green roofs, living walls. So all those can be inputs. What we get out are some of these things we're trying to understand. Wind flow, outdoor thermal comfort, how much, are we helping the buildings cool down at the district or city scale? And air quality comes along with it. So understanding pollution and airflow. What that allows us to do is start to understand a climate response from a city that's overheating, and the more energy and water we use to keep the buildings cool, those buildings are often rejecting that heat into the outdoor environment. So we have, a declining user experience on the street. And so can we reverse all that? And can we understand how to model some of these natural vegetated systems and understand things like evaporation and shading and infiltration of stormwater to look at multi-benefit solutions where maybe we can even start to aggregate some budgets around air quality, budgets around water quality, budgets around stormwater, budgets around infrastructure upgrades that we might not have to make if we're applying vegetation for other purposes, but it's actually solving more problems than we realize. How do we get that all in the same spreadsheet? Very difficult to do. At the end of the day, it informs us in a way where we can understand where we're coming from. We can use baselines from pre-development. What happens in the future is not trying to be pre-development. We live in a different time, different climate, different needs. But how do we update and how do we understand where we come from and where we're going? One example of that is a new campus Microsoft is building in Sunnyvale, California, in Silicon Valley. And this is about a 4-acre rooftop that you're looking at. It's almost all native vegetation, intended to do all the things that we've been talking about: collect stormwater, improve air quality, provide an outdoor experience. In this case, it's also attached to the ecology of the adjacent stream, and cool down the building and the environment as well. There's very much a user experience involved. So these are renderings of mostly of the roof. The upper right and lower right are both ground plane. Obviously, the background there is ground plane. Left side is all kind of roof as it's being built. And the idea here is that you could literally drive into the garage, go all the way up to the green roof, have an experience that's different and fulfilling and enriching and maybe inspiring, and then drop down right into your work unit from the roof down and maybe get a cup of coffee on the way. There's a deeper level of inquiry here that Microsoft is interested in. Has to do with biophilia, has to do with wellness, has to do with human performance. And a lot of that is related to happiness, but also some very measurable things, whether it's sick days, showing up early versus showing up late to work, longer and shorter lunches. What people like Bank of America and McKesson have found is that if you have these experiences with natural systems, healthy, productive landscapes, and even better if there's habitat, that triggers things in our physiology that actually make us more productive. And so many of these companies are actually looking to integrate these things, not just for technical reasons, which obviously are really important. It's the reason we've been building most of these things, but now actually for people. Imagine that. So it's all converging, I feel like. What we're learning is that the natural system that we evolved with actually makes our habitat better, performatively, as well as from a public health point of view. And so really trying to look at how we can get higher productivity, have our kids learn better, have people happier at work, more, happier to be there, also getting more done, more productive, higher value, but doing that while repairing our infrastructure and our biosphere and ecology. Google's also very interested in this. Another campus we're working on with them. The Microsoft campus, I should have mentioned, is net zero water campus as well. So all the water is being recycled and reused. Same story at the Google Bayview campus. This one's also under construction and nearly complete. It's equipped with an on-site water reuse system that recycles 100% of the water and gets them to net zero as well. Even potentially, it's set up for future use that could even export non-potable water to its neighbors. So trying to understand how a district scale on-site water reuse system might work and how that can be integrated with ecology. So these are stormwater ponds. Nearly 100% of the stormwater on the site is caught on site, and that's blended into the recycled water from sewage. So you have multiple water sources that you're able to modulate, and you can also modulate that for habitat. So how those ponds are kept at certain levels seasonally and the appropriateness of ecology also fits into that, and there's obviously a user experience component. Taking that to a place like Los Angeles, Pasadena, can you build out a campus in an area where infrastructure is already so taxed that actually taking water out of the sewer line, the public sewer line, recycling it and using that recycled water to rehydrate your campus so you can get trees and shade and evaporate water like crazy and cool down the entire district or the entire campus, using that wastewater supply that's actually reducing impact on downstream municipal infrastructure. So, if a trunk line is having a hard time handling it, rather than building 5 miles of new, larger pipe, disrupting traffic, spending a tremendous amount of money to get the pipe you thought you already had, take water out of that pipe. The pipe now continues to work for decades into the future just fine, and you use that water to cool down your city immediately locally. So hyper-local, demand-based sewage treatment from the pipeline, and using that as a very inexpensive source of low-quality water for subsurface irrigation to help cool your city. What we found in some of the CFD studies is if you had unlimited water, using University of Arizona research, you could have up to 10-degree drop in temperature on the same block, just from shade and evapotranspiration from plants and trees. So imagining those kind of shifts, can help us with brownouts and blackouts due to air conditioning demands, for example. So a lot of good information to suggest that this kind of approach could be helpful. Some of our studies showed it could be up to twice as expensive to respond to climate change by trying to cool all the buildings individually versus spending that money at a district scale to cool the whole city down. So looking at sort of what it's going to take to respond to a few degrees of climate change. And then taking a shift to how the form of the city is changing watersheds specifically and stormwater. And I think this is really important to understand. So this is very general and very typical, taken from US EPA, and it's an old diagram, but it's still very true. If you look at 25% shallow infiltration, that's going to go sort of laterally into your sort of annual stream flows. 25% deep infiltration, that's going to go deeper into sort of multi-year processes very often. Depends on geology and things like that. But 50% of the water that falls out of the sky going into the ground. And what we see here is in an urban environment, typical, that's gone from 55 to just 15%. So we no longer have that water in the ground available to plants to evaporate. And we also have no water in the summer in this deep groundwater to keep our streams flowing. And you see fish suffering and empty streams and poor water quality. It also makes for a bad urban amenity when stream that doesn't flow in the summer because you don't have this infiltration happening. The flip side is if you look at the change in runoff from 10% to 55%, all of that water that didn't go into the ground is now immediately going downstream and causing great increases in flooding. So flooding has definitely gone up, and infiltration has nearly disappeared. Most people don't pay that much attention to the 40 and 30% evapotranspiration, but if you take it in an isolated situation, it's a 25% drop in the amount of water that's going up into the sky, and that's our rainfall. So we're actually dramatically changing our environment with sort of typical conventional urban development. So we're trying to find underutilized urban spaces. Are there places, in this case under a freeway overpass, where we can start putting some green infrastructure in, slow down that water, prevent the flood, get it into the ground so that that stream keeps flowing longer, and sort of restore the hydrology and the natural functionality of our watershed processes, even though we're in urban environments. So one of our staff, Haitham Shada, who is in Atlanta, participated in a studio with you at Georgia Tech, looking at some of these exact things, starting with Atlanta and its sort of overall big watersheds, and trying to understand what it wants to do. Oops, moving quickly. Sorry about that. So looking into plaza mapping, which is sort of like places that are supposed to be plazas, but they're kind of blah. And trying to understand where these underutilized spaces are, where are the opportunities to do something interesting, and zooming in at the sort of top of the watershed at Woodruff Park and trying to see where opportunities might be within that sort of heavily urbanized fabric to relieve pressure downstream where we know we have flooding and it's difficult to really do anything. And historically, we're sort of the last to be developed and continue to have problems today, typical of many cities, if not most, I dare say. Looking at what those opportunities are from a technical standpoint, a lot of rooftop opportunities to slow water down, catch it as soon as it falls out of the sky, put vegetation there, help cool down the city a little bit during temperature moments, but also help those big flood events sort of decouple the moment when all the water arrives downstream. And looking for opportunities on the ground plane and using a park as kind of a scaffold for that. And then looking into how that really translates into a sort of user experience, and how does that become a biophilic asset in the city, help people have better interactions, help with water quality, help with air quality, all of that stuff, in addition to just that technical underlay. And then I'll just move quickly through a few more things, and maybe we can have a conversation about some of these things. Looking at a lot of different typologies for how to respond to rivers in cities. Cities have grown up against their rivers, and very often the river is no longer willing to stay in its place. And so this example is in San Jose, California, looking at riparian urbanism. If you're in nature and you're walking across a space, you can see where the river is from a very, very long distance away, because the landscape changes, the vegetation changes, everything kind of shifts, and you can identify it pretty easily once you've seen a river. In the city, we kind of have an expectation that the city will be homogeneous right up to the levee, and then the river is inside the levee, and that's where it's contained. And I think it's intuitive to any of us that that's not how rivers work. They get bigger and smaller seasonally. And so we started to ask the question, shouldn't the city also start to change as it gets close to a river to accommodate that different condition? Can we have water sort of in places safely, where it comes out of its bank? And maybe we have some streets that are dropped, and for a little distance from the river, it occasionally floods in the street and goes back down. But it doesn't flood buildings downstream. You have to do that at scale. Also looking to restore the ecology. In San Jose in particular, there are some very urban spaces, and we're looking at ways to sort of integrate those. But also there's amazing habitat. There's salmon and steelhead and beavers and river otters and bald eagles and great blue herons and kingfishers right in the heart of Silicon Valley, in the downtown of the 10th largest city in the United States. So is there a way to have both of those things? Because I think we all can understand something's going to break, but maybe not. Maybe there's other assets around climate change response, around stormwater containment, flood control, public health, air quality, how do we measure these things? How do we integrate them? The LA River is another amazing example, and I'll finish with this project that we're working on. Most people don't think of this when you think of the LA River. You think of Terminator 2 and the semi race, or one of countless movies along those lines. But there are sections of the river, and the one we looked at in particular, we were asked to look at, is this section around the Glendale Narrows, and it's specifically in Elysian Valley. So we've been doing a little bit of work there, trying to understand the sort of macro. It's interesting to look at the history of the river in 1938 when they started channeling it because they had a giant flood. We haven't had a storm that big since, and it almost looks like they're starting to get smaller. I would attribute that to the success of the city with green infrastructure and implementing, new policies and doing new projects to try to control stormwater and flooding. It also looks like they're becoming a little more frequent, though. So it seems like, maybe we're winning the battle as far as size, but we're not winning the battle as far as how often they're happening, and some of those are still pretty risky. So there's some interesting trends that can be gleaned. And really looking at, for example, in many cities, this lower left is showing many cities, including places like Beverly Hills, California, and Santa Monica, Los Angeles area, are actually pumping groundwater routinely out of basements and parking garages that are underground, because there remains groundwater. And typically that goes into a stormwater system. Well, we're finding that can be habitat. It's clean, cold water from the groundwater. And so we have to be careful to just stop doing that. Actually, to some extent, species are relying on that. But also looking at other dynamics and looking at the river itself and looking at how infiltration might help, how parks might help, flooding, detention, retention, many of those things. Ultimately looking regionally and saying, look, solving some of these problems hyper locally within neighborhoods is incredibly invasive. Can we look at more of a watershed approach and see where there might be a quarry or a playground or a golf course or some other facility that's floodable? And in many cases that is possible. We also look at infiltration. So can we divert that water into places that are able to absorb it into the groundwater? Ultimately came to the conclusion that to really be able to save the ecology of the river and start to restore it and help with LA's 90,000 trees program by maintaining all the trees in the watershed and actually building on that sort of infrastructure armature, to utilize all that upstream opportunity probably requires technology. And so for us, there's a really interesting frontier around joining technology together with ecology. In some ways, the 10,000-year-old technology. So we're on the cutting edge of that. How do we use computers to help control infrastructure to make flood response very precise so that we can reliably occupy that space with amazing, beautiful amenity, biophilic flood control that's helping our cities respond to climate change? So I'm going to leave it at that and look forward to having additional conversation and look forward to seeing questions as well. Thank you.
Thank you, Josiah. I think Mike and Josiah, if you can both turn your Josiah, keep your video on. Mike, turn yours on, and look forward to listening to you two.
No.
I think I hear you, Mike.
Figure out how to get my face on here as well. But I will start by asking you, you've talked a lot about these campus projects with Microsoft and Google. Has any city retained you guys to say, take a look at our entire city and how can we do the best we can to implement your programs, your ideas for the next 30 years? Okay? It's almost like...
It's interesting.
So go ahead, please.
Well, no, it's funny that you say that, because I took one project out because stuff I wanted to talk about, and that was a city called Semarang in Indonesia that did hire us actually to look at the whole city with the Dutch, with Delterra and One architecture, and we did actually, in fact, look at an entire city for all the way from the upper watersheds down through the neighborhoods and out to the coast, and integrated most of the things that I just talked about. But it was a little obscure, and I was afraid it was going to go on and on.
Okay,
But that's something that I could talk about.
But you mentioned LA. When we did our red fields, green fields, there was clearly some cities that had water as a major issue and flooding as a big issue. And one of the ones I think about most of all is Houston. I mean, Houston went through Harvey, and Houston's got these bayous, and they've got concrete all over the place. If you would recommend to Houston, and their city encompasses the most geography square miles of any urban space in the country, so that you only have to convince one city council and you get the whole thing done. What would you recommend to the city of Houston? What kind of plan? And maybe it's a taxing system where you tax impermeable space, or maybe it's, so what would you recommend to Houston to manage, to implement your ideas in a 30-year time frame?
You're putting me on the spot here, Mike. I have thought about Houston a little bit and have done some work there. I think two things that come up that are interesting right off the bat. One is that they actually intend for their roads and highways in many cases to flood. That's sort of the last ditch flood conveyance system, and it's actually pretty brilliantly put together. But as a result, some of the more sort of provocative photos from Houston are really just the intended roads flooding. But we do obviously see bigger events. I know you're a civil engineer, so I think we would both probably recommend that they don't allow housing to happen below spillways anymore. That would be a good start. But for the city itself, I think the bayous are really important. I think restoring the natural hydrology and function of the bayous. We did some really good work, I thought, in Memorial Park there. And that's some of this work is integrated. And so I think, some of what you talked about early on, using big parks and using existing natural systems as sort of armatures to build your green infrastructure off of. I mean, the problem is everything is so low there. So it's hard to get things to flow.
Right. You started off with Brooklyn Bridge Park, and Brooklyn Bridge Park is one of the great recent parks built in our country. But did they think about Brooklyn Bridge Park as sort of a flood control system first, or did they think about it as a park first and then they added that on afterwards?
I'm not sure, to be honest, what they were thinking, but clearly it needs to do both. I think more than I do think that it's a coastal entity, and I think they're all very aware that that's necessary there. So I would say both, but I think that Sandy was a big lesson in really, meaning it. Like, right. You got to do it. Your topo line has to be consistent all the way through. You can't have any gaps. It's got to be a dike.
Right.
And I think Brooklyn Bridge Park, what that park shows is that you can do that effectively without it being what your experience, right? You don't go out there and think, this must be to keep waves from coming in. It doesn't feel that way at all. That's not how it's experienced. And I think that's the big win.
Have you had any work where you've taken water feature that was channeled up with concrete or whatever, and you opened it back up and you see what happened to the surrounding areas? I'm thinking specifically of what Greenville, South Carolina did with their waterfront area, their little creek downtown, and just a few of these, smaller projects that ended up with big impacts.
Yeah, I mean, we're doing some work with the city of Mountain View and the city of Sunnyvale around some historic drainage channels that are lined and trying to figure out how to make those wider and nicer. We're also doing some work, as I mentioned, the Guadalupe River, looking at that. We've proposed it in more places than we've built it, I have to acknowledge. We did some work with Dark Angles Group for Resilient by Design competition in San Francisco. And what's proposed in that design competition, I think, is an amazing example of opening up a channel like that. But yeah, we've tried it a few times. It's been done successfully by many others, obviously.
Yeah.
So, I mean,
Denver's doing a nice job with the Pratt River, and Nashville seems to be doing pretty well with the Tennessee River. So.
Yeah, where there's space, it's easy, and when you don't have space, it's a lot harder.
Now, have you thought about, they're talking about an infrastructure bill, and do you have any ideas on how we can get the federal government? Oftentimes they say this is a local problem. The local group has to solve that problem. And then I think that at the same time, they get lobbied by the highway funds and the railroads and, the electrical grid and all sorts of different groups. And they think about green space and green infrastructure way down at the bottom of the list. Do you have any thoughts about how you can get funding through an infrastructure bill on a national level, and what kind of incentives, maybe if you're part of the flood control area, that you can provide incentives to have dual infrastructure?
Absolutely. I mean, I've never seen a problem that collaboration couldn't solve. I feel like in many cases, so we have the Green New Deal, we have infrastructure bills coming forward. We know there are large budgets aimed at these issues. I think the multi-benefit aspect of it is what's important. I think there's plenty of money. I just am not sure that we spend it collaboratively. I think if the highway people who had an issue brought their suitcase full of money to a collaborative meeting, and the ecology people brought their grant program funding, and the stormwater people brought their funding, and the community parks people brought their funding, and you actually pointed all that money at multi-benefit passive solutions that are better for public health, better for equity, better for the watershed, better for climate response. I mean, I think the money is there. What we're missing is the mechanism for putting all that money into a singular project that's multi-benefit, instead of a ton of projects that are all single benefit and often in conflict with one another.
Right. I agree with that completely. And I have your work found that the sustainable infrastructure, sustainable green infrastructure, is more expensive, less expensive, about the same as what you're trying to solve in another way.
Well, you could probably answer that question better than me, but I will answer it in my own way, which is to say that for 30 years, I've been doing this work with green infrastructure and trying to understand urban systems. And over and over again, the answer to your question is, if you get the right stakeholders and you internalize rather than externalize the problems, what you find over and over again is green infrastructure solves many problems at once. That's the way it works. It's carbon sequestering, it's temperature modulating, air quality, stormwater, user experience, public health. So if you are able to aggregate those onto a single spreadsheet, it's cheaper every single time. Generally speaking, if you're only trying to solve one problem, it's usually more expensive. So if you understand all the benefits you're getting, then it's always cheaper. The question is, how do you, how to tally that? And that's a lot of what we're trying to do with these engineering tools. Let's bring these benefits into an environment where we can quantitatively evaluate them, and then bring communities together to understand how they can make their communities better while solving their problems for less money than it would take to do it the way we've been doing it.
So let me ask you one more question, then I'm going to hand it back over to Ellen. This has to do with a couple cities I'm familiar with. One in New Orleans, post-Katrina, and I think it was a $10 to $20 billion Army Corps of Engineers project to block the water from coming in. And then Charleston, South Carolina, where the Army Corps of Engineers once again has said, if you build a $2 billion wall all around the peninsula of Charleston, you can block the water from coming in. Can you talk about that type of solution from your perspective, and where you sort of force nature, sort of force nature not to behave the way it's supposed to behave, and rather let nature behave and you adapt? So,
I mean, if you look at the history, it's an incredibly expensive approach. If you look at the Arc, I don't think that we could say that those big projects have been cheaper than other solutions may have been in hindsight, right? And I think we could also say that they're not as reliable as we thought. Over time, we see those big infrastructure systems. The LA River is not infallible, nor is the Mississippi, despite massive heavy infrastructure spending in those watersheds, right? So I don't blame the Army Corps. Like, I've worked with the Army Corps. I find their models to be incredibly accurate and helpful. I think the problem is that they have been hedged in between two levees and told to solve the problem. And you can't solve a river between two levees. And so what we're starting to see in places like San Jose, California, where there's some shared responsibility between local agencies and the Army Corps. And in some cases, the Army Corps is like, hey, we want to let the locals take it on. Tell us when you're ready. We're here to like keep you FEMA safe and out of the flood. But like, if local communities can come together and find ways to resolve things, they're not pushing that agenda. They'd be happy to back out of that, right? And I feel the same way in the LA River. They're more than happy to let the local agencies and communities come up with solutions that aren't so constrained, right? Like, their jurisdiction is very narrow, and solving these sort of citywide problems within two levees is a huge challenge that no one would really want to have to solve. So once again, I mean, I think that they're a valuable backstop that's there to protect us all. I think that we're in an era now where, to the extent that local communities can come together and spend this money we're talking about in ways that are multi-benefit, that can provide the kind of solutions we're talking about. I think it's Lynn Margulis who came up with the calculation that the planet would be 25% hotter without the living systems. So the living systems are actually what's bringing it from unlivable for human beings down to livable. So when you consider what we've been doing with cities and urbanization and population over the last 200 years, say, we have removed systematically a lot of that 25% temperature technology and replaced it with just thermal mass that's generally producing carbon. So I think we're sort of at a point where, if you look at cities as geomorphology, we've sort of figured out sort of the structural component of like reshaping the surface of the planet, but we're still learning how to put a living epidermis on it that functions the way the rest of the surface of the planet does. And so to me, I think rather than talking about jurisdictions, I think what we're talking about is, as a society, a culture, how do we learn how to work together to put that living epidermis of high performance, natural passive systems that evidently make us healthier at the same time. It gives us better user experience, makes us more alert, more creative, more active, more aware. We heal faster, we learn faster. So if it makes us do all those things better, and it also makes our infrastructure work that much better, it seems like what we're learning to do is how to work together to stitch that back together in our own habitat.
And I know Ellen's ready for me to hand it over, but one last question: do you ever think about the financing aspect of some of these ideas and projects you have, and how you can convince the city council or whomever that if you implement this type of impermeable tax on properties or something like that, you can clearly create the money to provide some of these changes?
I mean, absolutely. We can't build anything that doesn't pencil out. Sometimes I run an innovation lab, so sometimes we propose things that don't pencil out because we think they would work really great, and we think they'll pencil out sometime. But 90% of the time, what we're doing is we're proposing things that can be built responsibly. And what we're finding, across the board is that there are almost always ways that you can integrate these types of solutions less expensively than the convention. And, it takes creativity, it takes design teams collaborating, engineers, architects, urban designers, landscape architects, working together to optimize. But if you can create those conditions, it's very rare that I find, a pro forma that says, gee, we should just probably do conventional development. It's cheaper. In nearly every case, if that's what the spreadsheet says, there's an oversight, in my experience.
Okay, well, great, Josiah. Ellen, should we open it up for questions elsewhere, or do you have a few questions?
Absolutely. I'm delighted this has just been fabulous. Listening to both of you, I'm making notes. I'm already kind of revising my syllabus in a few ways. And there are a number of questions. I have my own questions. I also want to respect and invite more of the audience to certainly post questions in Q&A. And I would say, picking up on exactly where the conversation just was, there are a number of questions about implementation and financing, and sort of what the hurdles are. On the one hand, are the hurdles also relative to trust issues, communities that have had flooding problems, they've been promised things, especially minority neighborhoods? How do you build the, trust on that? Others sort of asking similarly, but just even, is there skepticism? Do you often run into skepticism that, well, we know pipes work. How do I know this is going to, you're throwing some plants in a depressed area? The skepticism issues. So there's questions on the sort of implementation from that side. So why don't we elaborate a little bit more on that side?
Sure.
Well, yeah.
So much in there. I mean, that's a really rich question. So, absolutely, yes. I want to start with maybe the most important thing, which is like social equity and infrastructure and trust issues. You mentioned that early, and especially along rivers, but we see this in Atlanta, we see this in Los Angeles, you see it almost everywhere. Compromised communities or, at-risk communities or just poor communities, very often communities of color, are not in the best real estate. And there's a legacy to that, obviously. So we see these communities that are really taking on the brunt of flood risk and things like that. And so when you go through to, say, widen a river in a city, those are the communities that are most likely to be impacted. And, we have definitely run into situations where this is where multi-benefit is really important, right? Like, if we're looking at public health and we're looking at social equity and we're looking at ecology and we're also looking at public safety and infrastructure, but we're looking at them all together, what we find is, a solution, usually flooding, eventually starts to break the other priorities. And so, what we do typically in that situation is look locally, because it's the fastest, most expeditious place to do it, to see how much of the problem can be solved there without breaking those other values. And once you start breaking those other values, you start looking upstream. And you're like, okay, how can we soften the event so that we don't have to disrupt the neighborhood to solve the problem? And once again, it's possible, but it takes collaboration. Now you're working with other neighborhoods, you're potentially working with other cities, you're working at a watershed scale. But to me, that's just a really, really important process, and that means including those people. You don't know if something's broken if you don't ask them. You can't just assume, right? So getting that feedback and understanding where the tension point is and building trust so that communities believe that you're not just trying to like steamroll them, but you actually legitimately want to know where the edges are, like how much can the community contribute before we have to start looking for other answers, right? Moving, toward some of the other trust issues around like pipes and things, when I was an activist professional in my 20s, I was a landscape architect trying to do green infrastructure and wanting to get some of the budget for that from pipe downsizing. And civil engineers didn't trust that infrastructure in the 90s. So I was constantly fighting that to the point that I actually eventually partnered with a civil engineer and created a company called Design Ecology before I came to Sherwood that was self-certifying. So because there was a trust issue between my profession, landscape architecture, and civil engineering, right? Now civil engineers are writing the plans for how to use green infrastructure to downsize infrastructure and capture that value, right? So awesome. The industry has moved substantially. Can't take credit for that, but definitely felt like I was along for that ride. I think now what we're looking at is the same exact process. Now we're saying, oh, hey, actually it's not just water in a pipe and pipe sizing, it's the whole city. Like all the things that are going wrong in the city can actually be attenuated. And I'm not saying it's a silver bullet that solves everything, but multiple times we've talked about 1 to 2 handfuls worth of benefits that can come from these integrated green infrastructure systems. And what we need is, that's part of what we're trying to do with this modeling, right? If we can validate and provide predictability around not only the performance, but also the cost of inserting these solutions, then I think we can start to get certainty. You start to build data, you start to see how it was engineered, how it was designed, how it was built, how it performs. So it takes some time. And, we've seen a lot of green infrastructure built, and I think we're seeing more and more great white papers coming out of universities and from, progressive firms who are doing that work. And so it's great to be part of that conversation and that effort. And I think that, it's a trust relationship that we're building within the disciplines. And as part of why I'm very excited about urban design and civil engineering, having a better relationship, having a collaborative, ideative, creative relationship.
I'll say something, Ellen, about that, especially with urban parks and diversity. I think there's been an understanding about today that when you design an urban park, you need to design it for diversity. And Josiah was involved with Brooklyn Bridge Park, and I thought they did just an excellent job of making sure the amenities associated with Brooklyn Bridge Park were serving the entire community, not just the people who might be adjacent to Brooklyn Bridge Park. And as a result, you end up with a diversity, and I think everybody feels like it belongs to them, and it's not just about gentrifying the neighborhood. And so I think it takes the trust, it takes the communication, but it also takes a purposeful design about this is a space that should be used by all the people you want to be built for.
So continuing a little bit with the discussion of that in terms of, who benefits from green infrastructure. Clearly, we can, I think, Josiah, you've made a fantastic case of all the multiple cascading benefits. And one of them is obviously beauty. Green infrastructure tends to be beautiful compared to gray infrastructure. It increases property values while it's also doing all the health and hopefully is doing the equity and the ecology and everything else. On the one hand, we could there's some questions about who should be paying for this? Public sector, private sector? Are we scaling up to the scale of a federal infrastructure bill that really, puts a lot of public monies Or are we at a tipping point sort of for that? Has it mostly been private sector? Where are we? Who's paying for this stuff and who should be? And I leave that to both of you, really.
It's been all over the map. It comes from everywhere, and it comes from public-private partnerships. It comes from private development. It comes from public sector. The benefits are where they are. I'll go ahead and say, we seem to be running into not only is our climate volatile, but our financial system seems volatile. Like we have how many bailouts are we all going to live through in our lives? In 2008, we gave bailout money to the banks and they sat on it and people suffered for a long time. I used to joke at the time that we should have given it to homeless people because they're going to spend it immediately and it's going to touch every hand. It's going to end up at the bank anyway. Maybe that would have worked better, but I don't think anybody would go for that. But I do think infrastructure is a perfect place. I mean, maybe we do it strategically when we have trillion-dollar bailouts that need to happen or incentives to jumpstart our economy. Why would you not put that into something as durable as your long-term infrastructure? And why would you not do that in the way that benefits people and needs? And to me, green infrastructure is a very difficult competitor when you consider it in that lens.
I think the cities are being very creative on trying to find new ways to finance things. You look at the Beltline. The Beltline started out with a tad on just commercial properties. They're trying to expand it now to the residential properties who are starting to benefit from that. It sounds like they are generating some substantial cash flow on a regular basis from just the incremental development that's associated with the Beltline. That type of TIF or tax increment financing strategy has been used around the country. Oftentimes you have situations where both Philadelphia and Boston and Washington put in business improvement districts. When they put those in, these businesses self-tax themselves to add more money that can add benefits to their area. But at the same time, they're saying, well, we will self-tax us, but we would also like some of our existing taxes and some monies that are coming elsewhere to come into this project. And so when everybody, and then this is where I think the federal government in one area has been lacking in this, and especially with respect to supporting the financials issues we've had. The Federal Reserve and 10 years ago with the financial crisis and today, I mean, everything they do helps inflate the financial assets. They really don't support the local economies. So I think the Federal Reserve.
Along those lines, I should mention. I was just going to say I should mention what I would have said if we weren't staring down the barrel of a pandemic and a likely big bailout, right? Which is, we have found that for resilience as well as sort of business continuity and direct CapEx reasons, most of this stuff pencils out for big private developers and campus scale type work. I work on a lot of campuses because they're a single owner district, so it's a simpler way to build infrastructure that size. We've kind of zoomed in on that size infrastructure because once you make the investment on the permits and everything else, you want to have a certain amount of size. But we often look at the cost of not needing to do something from a city's point of view. So if you're a municipality and you need to replace pipes because they're too small or because they're getting old, what's the opportunity cost of not having to do that? And can you incentivize a large upstream landowner to install infrastructure that extends the life of the public infrastructure? And to me, that's the way public-private infrastructure really can work together right now. Our grandparents built amazing infrastructure. It's not that there's anything wrong with it. It's just not big enough for most of what we're trying to do. But if we can start moving the infrastructure upstream, and instead of old, antiquated updates happening at the bottom of the pipe. We have new, next century, next generation, high-tech infrastructure at the top. Then the old infrastructure just becomes the backup system over time.
All right. I want to shift us a little bit, come down home to Atlanta. And two questions. One is, I loved Josiah. I really had not thought much about the evaporative cooling provided by all the vegetation, and love adding that to the urban heat island toolbox. But in Atlanta, our humidity is just horrendous. Does that evaporative cooling really work in the places with high humidity? You're out in California, I get it, but please tell me it does.
No, well, you have a different issue. I think what everyone in Atlanta knows is that shade helps, and that trees can provide that. And when you have a neighborhood with well-established mature trees in Atlanta, your rent goes up. Simple as that. So to some extent, I think shade is just pretty important. But yeah, no, heat in tropical places is a different story than heat in arid places. And, you get diminishing returns on evapotranspiration for sure as humidity goes up.
Darn, I was hoping you'd fix that.
Listen, it's all relative, Ellen.
Nope.
I lived in Charleston, South Carolina for a while, and you talk about humidity. Atlanta feels like there's no humidity at all here. So
we do acclimate. We do. So now another question. Howard Wertheimer asks, what big moves do you think Atlanta, a city which has a combined sewer system, what can we do to help protect our river, and especially using our big parks, Piedmont Park, the new Quarry Park, and Howard has a lot to say, has a lot of potential to actually be to impact our Piedmont Park. I mean, what advice, if he's in control of one of our big central parks, and we've got another big one coming up, how can they help the river? What should he be looking at?
Yeah, it's not just the river either. We have these Peachtree Creeks, some of these creeks coming through as well that you can't find them, but when you do, they're sort of interesting. So anyway.
Absolutely.
I think it's all about getting as far up in the watershed as you can and implementing a somewhat ubiquitous fabric that's more absorptive and less slippery, right? So you want to slow the water down. Parks are amazing locations for temporary retention and infiltration of water. Getting that water in the ground, and even if you can't handle it all, getting it into green infrastructure system slows it down. So I think a lot of it is just decoupling in the low zone, then we're going to have flooding and we're going to have poor water quality. If we can decouple that by slowing the water down differentially in a more rough urban fabric that has maybe some green roofs and maybe some parks and even little interstitial streetscapes, but parks become the anchors of that system. When the water arrives in the streams and in the river, will be decoupled. So, you want that scary event to go from like a 4-hour window where everything happens and then it goes away to maybe being a 20-hour window, and maybe we have a longer period of alert, but nothing ever floods, right? Because the water's coming down in non-sequential ways. Or I guess sequential.
Yeah, makes sense. All right. There also are some questions on kind of scale and scaling up. So I know some communities have been successful at when there's a repaving, they have to just start repaving the regular neighborhood streets. They narrow them and put in rain gardens that residents adopt, and they're saving about 90% of runoff from the sewers and hitting the creeks. There's also the kind of this, when you talk about the district scales and campuses, obviously, yes, when you're single owner, we've got some amazing district scale systems. Emory University's Water Hub is a really incredible water recycling project locally here. But what I hear a lot of communities and certainly developers interested in are multi-property serving district scale stormwater systems. I mean, we could retrofit an awful lot of our suburban arterial strip mall fast food kind of landscapes. None of them are big enough to quite handle stormwater retention effectively on their site, but if they pooled together, you could get a great district scale. And folks have been talking about this. I see proposals, and I'm not aware of any of them getting built. What is the, and I hear, oh, there's liability issues. Why can't we scale up district scale, multiple owner district scale solutions?
I mean, I would let Michael answer that one. Very often it's about just stakeholder alignment.
Yeah, I would say oftentimes, the squeakiest wheel is the one that gets the oil, and the squeakiest wheel is the one that can get a project turned down. And so opposition oftentimes has been louder than positive forces in the past. And, I think it just takes communication and persistence and a group of people who are definitely determined to get something done. But that's why, if you could sneak through, say, a tax on impermeable properties, and then all of a sudden people are worrying about that constantly and how much taxes they're paying on, their asphalt, then they might change their mind because it's hurting their pocketbook. So, it's almost like you got to start with some way to start hitting people's pocketbooks. Then they start thinking about alternatives.
Yeah. All right, I want to switch now. I want to close out with a topic dear to my heart. Here we are at Georgia Tech. Are civil engineers being taught enough about urban design to really employ green infrastructure effectively, and vice versa? Are urban designers being taught enough about hydrology and ecology to really collaborate, to do all of the collaboration that, Josiah, you have managed, obviously in your firm, to do this, but we still talk about the silos, and they're still pretty prevalent. And I know both Mike and Mike, this is a topic you also have opinions on.
Well, you could talk about the civil engineers you hired, and I could talk about the civil engineers I've just recently interacted with in the last year or so teaching. But you've been involved with civil engineers in this practice for the last 20 years or so. So why don't you talk?
I think that for many years I used to joke that I was an integration consultant when people asked what I did. Trying to get disciplines to speak to one another, right, is so important, to just understand each other's mechanisms. I've been lucky to work in a lot of big room environments where everybody, for anyone who doesn't know, that's like a construction process where you just get all the designers into one big room, and it's usually a very large project. And everybody comes to all the meetings. I mean, it's not that coarse, it's not that blunt, but I've sat in a lot of meetings with mechanical engineers, structural architects, geotechnical engineers, landscape architects, developers, talking about what their needs are and what the bleeding edge is and what conventional is and what a reasonable place to land in the middle is. And I feel very fortunate to be able to work in those environments because I know not everyone does. My innovation lab at Sherwood, we typically are multidisciplinary, so we're not all civil engineers. We're the only group in the firm that really has other professionals. And we've had everything from architects to building scientists to landscape architects. We had graphic artists in there. And so a lot of what we do is try to translate what's happening in our civil engineering silo with other disciplines through the lens of the Innovation Lab. So, Brooklyn Bridge Park, I can't take credit for Brooklyn Bridge Park. Jason Loisel and Jim Remlin, our crew out there on the East Coast really did that work, right? But as an Innovation Lab, we get to dip in and bring some different disciplines to bear and almost maybe pre-bake some places where we might set somebody off because we're not paying attention to their discipline, right? And then if it's a problem area, bring that person with that team to go talk to those people in that other discipline. You have a translator and a bridge, and you can get creative a little more and not just be the engineers who have to always hold the constraints and the lines, and that's not going to work. So I think a yes and approach, maybe there's 3 ways that a problem can be solved and not just one, and give those 3 ways to the designers early and say, look, we want you to bake the engineering into your design. If you do it this way, our problem is going to be easy to solve. If you do it that way, we're going to have to jump through all kinds of hoops and get really expensive. How do you want to go? How important is your design idea? Or does some of this engineering information inspire you to have a different design idea? That we leave that to the designers. But I think that giving them more information about the consequences of design decisions early allows designers to be better designers. And I don't think civil engineering does that well.
And Ellen, I would say that part of this is that the landscape architects and the urban designers need to embrace civil engineers as being part of the solution, and not think that they are up against roadblocks all the time. Okay, and I just think about the Redfields Greenfield studies, where we got these people in different cities understanding how important and valuable parks could be, and then all of a sudden they were talking with developers one-on-one. Okay, and recently we got the people at the City Parks Alliance explaining how parks can be infrastructure, and now they've got the American Society of Civil Engineers backing them 100%, and they've got the U.S. Chamber of Commerce backing them 100%. So it's really a case that you need some of the people who think that they're just out, no one pays attention to them, to say, we're in this same conversation with every one of you guys, and this is the reason why.
Oh, I would love. Please, I need more civil engineers to apply to MSUD. I absolutely welcome. We graduated our first civil engineer who came through MSUD in December. I'd love to have more. But I do feel that sometimes what I hear from the civil engineering students at Tech is they'll take either history of urban form that my colleague Richard Dagenhard teaches, or he used to teach a green infrastructure class. And I mean, the students would absolutely love, the civil engineering students would love these courses. But then we would run into issues that, I only get one elective in 4 years. Is this the one? We can't
get. That's right. You got to get dual numbers on these. Once you get the dual numbers on the courses, then you're in good shape.
Yeah, we've been trying. It's just there is a sense of I feel very strongly architects need to learn the city. Planners obviously are taking a lot of courses to learn about cities. But I think I'm biased, of course. I think everyone should be learning more about cities to be effective.
Definitely fire marshals.
Yes, yes, we need fire marshals. So
their decisions are so important to what happens anyway that they might as well get the urban design degree. No, I agree with you completely. I think that, as you know, we're excited about that work. I went to graduate school around LAUDs, MAUDs, right? Like certainly these hybrid, UD is almost conceived as a hybrid degree. It's usually someone who's coming off another profession, usually design. But when I start looking at these complex urban systems and understanding how modeling and quantifying some of these benefits, and not just green infrastructure, but massing urban canyons, the width of boulevards, how much heat is coming in on internal combustion engines to a downtown. If you exclude it from a certain district, will it cool down? Because there's a lot of BTUs. I mean, if you've ever touched your hood after driving for an hour, there's a lot of heat that these vehicles are bringing in, and tailpipes as well, right? So actually understanding all of these things through an urban design lens and walking around with data going, does anybody need this, right? I think there's a lot of potential there. I think there's some real benefit.
Well, I certainly agree as well. So I want to just thank both of you enormously. I apologize to the audience. We didn't get to all of the questions, but you've been listening to episode 18, Redesigning Cities with Green Infrastructure with Mike Messner and Josiah Cain. But now, before we close, I'd like to welcome a special guest to turn on his video and join us, Scott Marble, chair of the School of Architecture at Georgia Tech.
Hey, everybody. Can you hear me?
Yes.
Okay, great. Well, this was another amazing panel. Mike and Josiah, you guys, it was a great conversation and great presentations. And, this series has become such a key part of the school. It's really kind of created a buzz all around the country, if not the world. I noticed we had people from overseas again here today. So I just wanted to, thank Ellen for everything she's doing, but also Mike, thank you for the support you've given us. This thing has been, this program and series has been so much more than we could have ever imagined. And it's really brought experts into the discussion at the school that we typically don't have. It's brought people from different disciplines, from the professional world, from the research world, from the academic world. And it's really just had a huge impact. And I thought I would take this opportunity, Mike, now that you're part of this impressive list of participants, just to thank you on behalf of the school, and just let you know how important it's been and the impact it's had. I think not only on our school, but it's going to be part of an ongoing discussion on these big topics that Ellen has laid out. These are not small issues that we're taking on. I mean, I was looking through the list of the 18 episodes, and these are big issues. And I think this series has become one of the resources that will, help continue the discussion and hopefully lead to some solutions. So I just wanted to add that to the and thank you, Mike, for everything you've done.
Listen, I appreciate those comments. It's clearly, when you think about giving away money philanthropically, you want to make sure you get a good return on your investment. And this has been a great return on investment. And Ellen's done a fabulous job. And clearly, she's having a big impact on the future of cities just from these discussions. So I very much appreciate being part of it. So thank you.
Great.
Thank you. Thank you both. All right. Well, and thank you to the audience. We'll see you next time.
Okay.
Bye-bye.
Bye-bye.